In this video, I'm going to work two integration by parts examples. So here we have the integral of natural log of x dx. And I don't know any formulas for the integral of a natural log. So this is a situation where we would use integration by parts. As you can see, I've written our integration by parts formula up here. The integral of u v prime equals uv minus the integral of v u prime, integrating with respect to x. And then I've mentioned that we choose how to write our integration by parts, or how to choose our u, I should say, by using this formula Liate. L stands for logarithmics, I inverse trig, A algebra, T trig regular, and then E exponential. And this is my order of importance for how I would choose u. So in this case, because I have a logarithm, I'm going to say let u equal ln x. Well, what would be my v prime then? V prime is just 1 dx, or just 1. So if I differentiate, I take the derivative of u prime is 1 over x, and if I integrate and I find what v is from v prime, that's going to give me x, right? So I did the derivative of u and the integral of x. So writing this out, listing this, that's going to give me u ln x times v x. We have minus the integral of v x times u prime, which is 1 over x dx. So this simplifies. I've got x ln x minus the integral of 1 dx. And this can be written finally as x natural log of x. The integral of 1 is just going to give me minus x, and of course we write plus c. Let's look at one more example. Here we have the integral of x squared times e to the x dx, and we're going to use integration by parts to solve this problem. So we have two choices. I have two things that are being multiplied here. I have x squared and e to the x. Looking at my rule of thumb, x squared is algebraic. E to the x is exponential. So since algebraic comes first, x squared is going to be my u. U equals x squared, and that means then v prime is e to the x. So take the derivative of u equals 2x, integrate v prime, the integral of e to the x is e to the x. So this, when I write that out using my integration by parts formula, is u x squared times v e to the x minus the integral of v e to the x u prime 2x dx. So this can be simplified just a little bit, pulling out that negative 2. And by commutativity, I reordered x dx times e to the x. So a lot of the times, especially when we have some of these circular functions where the derivative repeats itself or the integral repeats itself, we might have to do two integration by parts. So I'm going to do this same problem, but I'm only going to look at this last piece here. So when I come down here and I repeat this integration by parts and I look at this, obviously I have an x algebraic and an e to the x exponential. So let u equal x, v prime equals e to the x. So when I differentiate u prime, in this case, see it's reduced down to 1 or a constant, and when I integrate, v is still going to give me e to the x. So here I have x squared e to the x minus 2. And repeating my integration by parts formula, that's going to be uv, or x, e to the x, minus the integral of v u prime. So e to the x times 1 dx. And of course I don't need that 1 there. This last piece, the integral of e to the x, is just going to be e to the x. So finishing this problem, I have x squared e to the x minus 2x e to the x, making sure we pay attention to this distribution, negative x, right here, that's going to become a plus 2. And then the integral of this last piece is just e to the x. So we can write our plus c. That is our final answer. Of course, we do always want to simplify as much as we can, and you'll notice that all three of these terms have an e to the x. So if I were working this out, I would go one step further, say e to the x. I've got x squared minus 2x plus 2. And from there we add plus c. So there we have two other basic integration by parts examples in this video.